All right, we're looking at the 6-3 notes for exponentials and logarithms. So, what I want to start with is just this basic idea. If I had 2 raised to the x power equals 16. 2 raised to the x power equals 16. Quickly, can anybody tell me the value of x? 4. Good. Good. What if I have 8 raised to the x power equals 64?
2.
Yeah, we could quickly determine that x equals 2, right? Cool. What about 8 to the x equals 65?
Mm-hmm.
Right.
Put it in a calculator.
Crickets, right?
Calculator.
What would you put in a calculator here?
This. Square root.
Yeah, it's not a square root, right? Where do we see the variable in this? In the exponent. So what type of equation is that? Yeah, so this is an exponential equation because the variable's in the exponent. Now, 65, she ain't friendly in any way, shape, or form, right? And if we wanted to, I could sit here and play a game of, guess and check until we get it, right? So we know that it has to be bigger than 2, so what power could we give it? 2.1. Yeah, or 2.5. Oh, okay. Well, 2.1 is still 18 or 13 off. So maybe 8 raised to the 2.01 power. Now we're only 3/10 away. 8 raised. Oh, not this 2. I didn't want that. Let's call it the 2.001 power. Okay, now we're getting there. But we're a little low, right? Because I want 65, not 64. So 002. Okay, 2.00. No, that's not what I wanted. There should be an easier way of doing this, right?
Yeah.
That's my point. I'm not going to spend all day trying to get this number over here to say 65. That's going to be really tough. We'd spend all afternoon trying to guess numbers until we get there, right? We'd have to go above and below, and get it to a certain point. That's inefficient. And the goal in mathematics is to be more efficient. So we have the definition of logarithms. And this is the definition of all logarithms. It says, if a to the x equals b, comma, then log base a of b equals x. That might be my best handwriting of all time. Glad I got recorded. The internet will forever have my greatest log. I dropped a log on the internet today. We don't do that? Is that inappropriate? Sorry about that, chat. Okay. All right, let's try this. Connor, help me out, dog. Let's go back to that 8 to the x. So 8 raised to the x power equals 65. Use your ability to pattern match. This is exponential form. What will logarithmic form be for that equation? What would it be in logarithmic form?
Log, and then a would be 8.
Yeah, so log base 8, yeah, of
65.
Yeah, equals. Yeah, good job, man. That's exactly right. That is exactly right. So I want to make sure I write this out because I want you to know what to say and how to say it. So here we would say log base 8, comma, of 65 is x. All right, so notice that we put our base as a subscript. Sub meaning below, like a submarine. Of this piece right here is called an argument. The equation, their equal sign. That equal sign in the English language is. That's the way it translates. Equal sign, is are the same. And then x on the right hand side. All right, so if I was a highlighter person, which I'm learning to be, notice that the base of the exponential form is the same as the base of the logarithmic form, right? So my base stays the same. The exponent is now on the other side. Notice that x is no longer in the exponent. X is now part of the main line, and it's easier. Now we have the ability to solve, right? And whatever the exponential form is equal to becomes the argument. So you'll often hear me say, what is the argument of that logarithm? Or we're going to take the argument and do something with it. So this is called the argument. And not in the form of disagreement. Not in that form. Yes, Elvis.
What is logarithm?
Logarithm.
Yeah, but what is logarithm?
Great. The meaning of a logarithm, and what's beautiful is that this is literally what I was about to write. And you're going to hate this explanation. Because I did until I discovered that it was easier to think of it this way. The meaning of a logarithm, actually, you know what, I apologize for erasing. I'm just going to leave it like this. The meaning, the logarithm is an exponent. What is a logarithm? The short answer, it's an exponent. Where was x? It was in the exponent. And over here, what does x equal?
Log.
So an exponent is a logarithm. Okay? All right. The exponent, x, is a logarithm. Was that any remotely helpful?
Yeah.
Okay, good. So here's what I want to do. I'm going to fire through a fistful of examples here. Make sure you're working through your notes. So we'll start with you, Connor. Rewrite this. Excuse me. It's no longer asthma. It was just fun.
Yep.
Connor. We know that 6 to the third is 216, correct?
Yes.
I need you to rewrite that in logarithmic form.
Okay. Log base 6
Let's go.
of 216 is 3.
Really good. Really good. All right. Elvis. Let's say we have x raised to the fourth equals 99.
Log base x.
Good job, yeah. That's exactly right. Great job. Really good. Will, use your patterns now. On our notes, the fun colored bits, use your patterns, and I want you to tell me if I have 4 to the x equals 9. That's ugly. I like it. How could I rewrite that? You didn't write that down, did you?
So that would be 4
Easy.
log
Yeah.
x 4
What? The base is going to stay the same. What was my base here?
4
Well, the base, not the exponent or what it equals. What is just the base here?
a
So what's my base here?
a
I see 4x and 9. Which one of those three things is the base?
4
4. So log base 4 of what?
X, no, 9 equals.
Yeah. Log base 4 of 9 equals x, right? So the reason why I use those highlighters is to make that pattern a little bit nicer for you. The base stays the same, and for me, when I was going through and learning to do this quickly, base stays the same. These guys switch sides. All right, trade sides, however you want to think about it. All right, what if we go the other direction? What if we start with logarithms? Can you rewrite it in exponential form? So, Elvis, help me out, dog. Let's go with log base 3 of 210 equals x. Keep it simple. All right, rewrite that as an exponential form. Perfect. Good job. Marissa, if I have log base m of 9 and it equals h. M to the h equals 9. Really, really good job. All right. Here we go. Wait a minute. Let's go with, let's try this. Let's go log base 1/2 of x plus 3 equals 67. LOLZ.
1/2 to the 67 equals x plus 3.
Really good. Good job. Yes. Yes, that's exactly right. You know, you're showing a little bit of growth, young man. That's a modicum amount of maturity, and I take it. All right, so let's roll it over, Smokey. Huh?
Was it you who came up with logarithms?
Dude, I wish I invented logarithms. You know how handsome I would be? Oh, I'd be so handsome. I'd be the most handsome. Oh, just as a heads up, you got 26 homework problems.
And they're all
A third of the homework problems are doing this. Half the homework problems are doing this. Just converting form from one form to the other and back. That's it. And then there's like 4 problems where you're going to have to solve an equation. Okay? So, there's 2 different types of equations here that involve logarithms. We're going to use them. I'm going to try this way. So, solve the following. All right, so you're able to convert from exponential to logarithmic. You got to convert from logarithmic to exponential. Those are the first 2 skills that you have to get pretty good at. Then we're going to ask you to solve some equations. So I'm going to break this into thirds. I like doing this. And let's go back to this example. 8 raised to the x power equals 65. Where's the variable? In the exponent. What type of an equation is this? All right, so we have an exponential equation. Okay. Hey, Connor, what do you bet? And this is a theme pulling from your Unit 5 test, bud. What do you bet the first step is? Not on this problem, but every problem ever. Every exponential equation that you're going to have to solve, what do we need to do first?
Oh, it's isolate.
Isolate.
I'm the inverse.
Well, Yeah, so
I, but I kept thinking.
step 2 is going to be inverse. Right? So first thing I want to do is isolate that term that has the variable. Right? So does 8 to the x, is there a number in front of 8 to the x that's being multiplied? No, so I don't need to get rid of that. Is there a number after 8 to the x being added or subtracted? No, so I don't need to worry about that. But I want to take the inverse. In other words, I need to convert. Right now, I have 8 to the x equals 65. How can I convert that to what? To the logarithm form. Like logarithmic form. How am I going to convert this to logarithmic form? Okay, so log base 8 of
65 is x.
exactly right. Yeah, log base 8 of 65 is x. Perfect. Now, because your teacher is very handsome and got you some incredible tools, let me just show you. Before I get to the calculator, here's what you need to know. Yeah, I'm sorry. I can't go full new school yet. I have to kick it a little old school. There are how many logarithmic buttons that you see on here? One. And his girlfriend, natural log. LN stands for natural log. Yeah, it's backwards. So, when I see log of something, let's call it x, it means log base 10. Alright, that's the meaning. The base is 10. It's understood. That's like we don't write the index for a square root, do we? No. We understand that the index of a square root is what? 2. If I see a logarithm missing a base, I understand that that base is 10. Because we count in base 10 system. Yeah. The Arabic numeral system that we use is in base 10. Why do we use 10? Stupid, but why do we use 10? Because we have 10 digits on our hands. Yeah. 10 fingers. All right? We do indeed have 10 toes. You're not wrong. You're not wrong. Except for that one guy who's watching this video because he's bored on a Saturday and he's watching this, and he was the kid who like chopped his thumb off in 8th grade shop class. You know what I mean? Do you know that kid? He's like, no, Mr. Stevens, I only have 9 fingers. And I'm not going to say that the rest of the world needs to convert to base 9 for him, but we're going to keep it at base 10. That's just a little easier for us. All right, anyways, if I see Ln of x, that Ln stands for log base e of x. Do you recall when we learned about e yesterday? E is called the natural number. Euler's constant is called the natural number. That's its nickname. So the natural number is why we call this the natural log. I will tell you, by the time you graduate college, if you have any interest in math and science, if you take any math and science classes in college, you'll be far more comfortable with natural logs than logs. Mainly in part because it's easier to write. Ln versus logs. Okay? So this is the natural, I can write good, log. It's the natural log because it's the base is the natural number. Now we write it Ln because it's a logarithm before it's the natural number. So that's why they use Ln. It's a logarithm. All right. All of this is to say, in my calculator, I only have 2 buttons. I have log base 10 and log base e, known as the natural log. Now, back in my day, you didn't have fancy calculators. So when you press log, you get base 10 naturally. And in my day, I didn't have a calculator where I could scroll over delete them numbers, and put an 8 down there. So I've changed the base to an 8. If you had the calculators that I grew up with, you would have to learn a whole series of steps to manipulate the calculator. You only need a 10 in a natural log, but I'd have to teach you how to use it. Fortunately for you guys, you get a calculator that's smarter than any other calculator before. All right, what am I going to put as the argument?
65.
65, good. Close that out and I hit boom. I get 2.0074559. Okay? So here we get x equals 2.007, and I am done writing. So we'll call it that. Let's try another example here. Let's try another example. Let's say we have 2.75 times e to the t equals 38.6. Let me know when you're done writing, Emmett.
Done.
What is the base with an exponent for this problem? Yeah, what is it, Emmett? E. E is the base. Now, Connor, is there a number in front of E being multiplied? Yeah, Connor, what do I need to do first to get e to the t by itself? Yeah, how am I going to do that? Divide by what? 2.75. Divide by 2.75. So now I get e raised to the t power equals, whatever on earth that is. 38.6 divided by 2.75. We get 14.04. We okay with that rounding? 14.04. All right. What are we going to do next? Yeah, we got to take the inverse, and we do that by converting. All right. So, Marissa, convert this exponential statement into a logarithmic statement. What's it going to be?
Log e.
Yep, log base e.
0.04 equals t.
Good job. Now, I'm not going to write that as log base e. I won't. What does log base e really mean?
Oh, it's natural log.
That's your natural log, right? So I'm not going to write it this way. I'm going to write that the natural log of 1404 is t. That seems a little bit more concise for me. Take it how you will. So what button am I going to press in my calculator here?
That one.
Yeah, so natural log, that guy. What's the argument?
14.04.
You got that right. I'm going to close my parentheses. Boom. 2.64. All right. So t equals 2.64. Okay. What, and then this is just like hypothetically speaking, let's try another example here. What if we had something like, no, sorry, my bad. The natural log of 3x minus 1 equals 2. Before we try to solve this problem, Connor, where is the variable for this guy? Yep, that's our x is the variable. Where is it in the context of this problem? Looking at the structure.
Inside the radical.
Is that it's not a radical, it's a, what's that big word we just learned? A log, right? My variable's inside the logarithm. What do you think the name of this type of equation is called? Yeah, it's a logarithmic equation, right? Where's my exponent here? On this problem that we started with, where's the variable?
Exponent.
It's in the exponent, and we call them exponential. Where's the variable this time? Logarithm. So we call these logarithmic equations. Hey, Connor. I'm so sorry for picking on you, bud. There's only 5 of you. Connor, what do you think the first step is to solving logarithmic equations? No, before that. It is another I word.
Would it be isolated?
It would indeed be isolate. All right, so once the logarithm is isolated, what are we going to do next? The other I word, right? And what do I want you to think about solving logarithmic equations when we get to an inverse? What am I really telling you to do? Convert. All right. So let's take a look at this logarithm here. Marissa, is there a number in front of the logarithm that is being multiplied? No. Good. Is there a number after the logarithm that's being added or subtracted? No. So it is isolated. Yay. Now, we have to convert. What is the base of this logarithm? E. Good. What is the exponent? E to what power? Say it again. E to the second. Yeah. And what does it equal?
3x minus 1.
Good. 3x minus 1. Now we have a very simple equation, right? We're going to add 1 and divide by 3. But that's only easy whenever it's a number we recognize. Right? If this was a 2, not e squared, but if this was just 2 equals 3x minus 1, everybody in this room has shown the ability to hammer out that no problem. The steps you would take if this was a 2 are the exact same steps we're going to take that this is e squared. E to some power is just a number. I don't know what that number is, but it's just a number. So what I want to do is treat e squared as a number. So what do I need to do to both sides? Focus is here. What do I need to do to both sides to start? Add 1. Now I have e squared plus 1. So I'm going to write that. E squared plus 1 is equal to 3x. Okay. Last step to get x by itself. Go ahead. Divide by 3. And I need to divide everybody by 3, not just e squared, but everybody gets divided by 3. So I'm left with x equals e squared plus 1 all divided by 3. And yeah, I need to correct that e. Now, on the right-hand side, I have nothing but numbers. And x is by itself, so I can now go to my calculator. I have such a hard time. Okay. Where do I find e? To the left of the natural log, underneath shift, right? There she is. That's e to the x. And I wrote pencil on it for some reason. So I'm going to say e to the second power. I'm going to scoot over there. Over. Now, I'm going to add 1. I'm going to take all of that and divide by 3. Elvis, what's the problem? I'm only dividing the 1. Yeah. So let me just do this. I'm going to go ahead and start with the division part, even though it's out of order, and that allows me to put the e squared plus 1 on top. Round it 2 decimal places. What do we get?
2.8.
I need 2 decimal places. You just gave me 1.
2 decimal places.
Yeah.
But when I round up the second one, it goes up to 8. 2.79. Round up to the 6, and it's just.
Oh, 2.796.
Yeah.
So then it's going to be 2.80. Yeah. If the directions are to round to some decimal place, even if it's a 0, still put the 0 there. I know zeros on the end don't matter, right? Zeros on the end don't matter. But when you're told, when the directions say to go to a certain spot, make sure you put it in there, right? Okay. Are we okay with that? Let's try one more. Let's try one more. Oh yeah, let's no. Oh yeah, let's do one more. Last example, and then that's all that your homework is. We have the log of x minus 3 plus 5 equals 4. All right, what's your first step? Minus 5. All right, minus 5. So now I have log of x minus 3 equals -1. All right, what's our next step? Did you already have it down, Emmett? Did you finish this problem already?
No.
Oh. What's my next step, Emmett? Switch it to exponential form. Yeah, we have to convert. Convert. I'm going to convert from logarithmic into exponential. All right, Emmett, rewrite that statement in exponential form. What do we get?
Wait, so would it be log e?
Ooh, yo.
Base e?
Yeah, what's the base? It was not specific. Did it give us a base here?
No.
No.
So would it be 10? Or would it
Yeah, good. A regular log, regular Joe log is known as base 10. We understand that to be base 10. Good. So, what's the exponential form here going to be?
10 to the negative 1 equals x minus 3.
Let's go. Let's go. Anybody know the value of 10 to the negative first by chance?
1.
It's what? 0.1. Sweet. Yeah. So 10 to the negative first is 1 over 10 to the positive first. Yeah, so 0.1. Perfect. And last step. Got that right. Yeah, man. Yeah. All right, questions, comments, concerns? I know your homework says 26 problems, but trust when I say this is probably going to be the fastest homework that you ever do. Once you get into the patterns, you understand the pattern over and over, yeah, this is going to be real simple.